Yep, we see the
Chungsoo and I are
slides.
going to take you through using Strategus to execute the network study. And so just to maybe do a quick recap of the previous 5 weeks and where we are on this schematic for generating real-world evidence. So starting with the first week and initiating a network study, we came up with the research questions. We're going to focus today on the fluoroquinolone study, and part of that research question was evaluated using database diagnostics, which was shown in week 2. And if your database failed any of the diagnostics, we would immediately stop the study on that particular database. But assuming that it did pass, week 3, we covered phenotype development, and week 4, phenotype evaluation, so that we could determine if the cohorts are ready for use in the study. And if they were not, you would stop. And so last week, Patrick walked through the analysis design choices and how to produce a JSON specification for the fluoroquinolone study. And so this week, Chungsoo and I are going to talk about how do you take those analysis design choices that are represented in the JSON document that Patrick produced, and how do we actually execute that to produce study results and study diagnostics, which will then be reviewed in the future weeks by George. And I think the evidence synthesis will be the last part of the SOS challenge itself. So at a high level, I just wanted to talk quickly about the Strategus pipeline, kind of the concepts behind it. And so the idea with Strategus is that it takes as an input the standardized design choices represented as JSON. So effectively the work that Patrick showed last week becomes the input into the standardized execution engine, which is Strategus. And out of Strategus come the standardized outputs, which will be CSV files holding the results, as well as some additional files that describe the data model that hold those results themselves. Currently, we have a number of standardized analyses that are supported inside of Strategus. These include characterization capabilities for running cohort diagnostics, for performing characterization of cohort features, for calculating incidence rates, as well as doing a time to event analysis and de-challenge, re-challenge analytics. We also have support for patient level prediction, as well as population level effect estimation, including the comparative cohort design and the self-controlled case series. So just to touch on a little bit of the Strategus software and some of the design principles and design thinking that went into Strategus. If you've been around the Odyssey community for some time, you probably know that most of our network studies have been done using R packages that have been either custom developed to answer a specific study question or potentially generated using Atlas. And one of the things we've learned over the years with respect to both of those approaches is that having a standardized representation of the study inputs as JSON is important so that there's transparency in all of the study choices that went in. So that is something that's been at the forefront of what we've been trying to do with Strategus. Another design principle that went into the design thinking of Strategus was having a way to modularly compose Hades analytic packages for study design. And I'm going to go into more detail on what that means in the next couple of slides. And then finally, one of the other pieces that we've employed over the years with our study packages for network execution is the use of RENV. And RENV is a package within the R ecosystem that allows us to declare which R packages our network study is going to depend on, so that we can create the R environment for execution and have control over which versions are being used. And so that is something that we have employed inside of Strategus, and I'll go into more details on how we make use of that. Currently, the reality is Strategus is still under development. So while we're able to make use of it, you may hit some bumps in the road. And as a community, we're going to work through those as part of the SOS challenge. So I just wanted to take a minute to talk about Strategus Modules, and you may notice the nice Lego car that I have up here in the corner. So we want to be able to build a vehicle that's capable of stacking up all of these modules and getting us to our destination of reliable evidence. And so to do that, we've built a set of modules that we can basically put on top of this car and get us to our destination. So the first set of modules that we built are in the characterization space, and these include modules for cohort generation, computing cohort incidence rates, performing cohort diagnostics, and doing characterization. We also have modules for performing population level effect estimation, including cohort method module and self-controlled case series. We also have an evidence synthesis module, but we're not going to use that at this time. And then finally, we have patient level prediction module and a deep patient level prediction module. And we want to be able to compose studies using these various building blocks, put them on top of this car and drive them to our destination. And so you might be wondering what's actually inside of a module, or how is the module different from the Hades package itself? So a strategist module is an R project. So it's not an R package. It's instead an R project that has a lightweight wrapper around one or more Hades packages. And it has the following responsibilities. So to Evan's earlier question, each module has an RENV lock file that declares the dependencies that it needs. So in that way, the module can stand alone and also set up its own R environment for execution. The module itself also provides functions for defining the module settings that go into the analysis specification JSON. So last week when Patrick took you through the analysis design, part of the code that he ran made use of the Strategist modules to create the JSON specification sections for each one of the analytic tasks we want to perform. The module itself also implements an execute function, and the execute function simply takes the JSON specification and then has code that effectively calls all of the Hades packages to produce the output. And that output is written as CSV files for sharing across the Odyssey network. That's something else we've learned over the course of, years of doing some of these network studies, is that we want to have the files written in a way that's transparent so that people can inspect the results before they're transmitted back to the coordinating center. So as I mentioned before, Strategist modules can be combined to accommodate different study designs. So for example, if I wanted to characterize different populations, I could assemble these two building blocks together. I would have my cohorts that are then generated using cohort generator, and then I can use the characterization module to maybe compute incidence rate, or sorry, no, to characterize cohort features or to do a time and event analysis. I might alternatively want to run a different kind of study where I would compute the incidence rate for a given target and outcome. And I may also want to do some patient level prediction on that same target and outcome. Kind of extending that example a little bit further, we could also just add on the deep patient level prediction and make choices on how we want to train and evaluate those models. And so tonight with the fluoroquinolone study, we're going to kind of use all of the modules, or nearly all of the modules, to go through and run all of the analytics for our study. So I just wanted to touch on some of the prerequisites that you need to have before you can execute a strategist study. So first and foremost, you will need a database with your OMOP CDM data. So you'll want to make sure that you've converted your data to the OMOP CDM and you've set up your database server so that you can run the study. Next, you'll want to make sure that you have the proper software installed. So that includes R and RStudio, Java, and the GitHub Personal Access Token. And the instructions for setting all of that up are on the Hades website. And I just want to do a quick call out to the GitHub Personal Access Token. So this setup for the personal access token is important because strategists will attempt to download packages from GitHub itself. And GitHub does rate limit how much you can download at one time. So having the personal access token configured and ready is going to allow strategists to be able to download all of the modules without interruption. Sometimes if you hit that limit, things may stop, and it's usually because you haven't set that token properly. As Patrick alluded to, strategist execution is going to be covered in 5 steps in less than 15 minutes. So the 5 steps are going to consist of how to download the project, how to configure your local settings, how to execute the study itself, where to go to review the CSV files and how to take a look at those, and then finally, how do we share the results with the coordinating center. So let's get started. So we're going to start by going to GitHub /Odyssey Studies /fluoroquinolone aortic aneurysm. We're going to download the zipped folder with the project. We're going to unzip that to a local folder, and then we're going to double click and open the fluoroquinolone aortic aneurysm project. So let me show you the steps to do that. Bring over my browser here. So hopefully you can see that here. So to start, you just click the code drop down. You'll see a couple of options, and at the very bottom, you can hit the download zip. that will download the project as a zip file to your machine. I can show this in the folder, and then I can just right click, at least on my Windows machine, I have a unzip folder. Jenna's demo was much cooler because Macs just automatically unzip your stuff. And within this folder, you will see the same files as you can see up here on GitHub. I can line those up a little bit better. So from here, you would double click the R project. And on my machine, it does take a minute for R to open. So I've already opened it over here. So you can see all of the files that are in the project here. And then we're going to talk through how to get going with the configuration of the project. So after you open the project, you're going to see all of the files in the file system like I just showed. And the first step that we want to do is go through and click on the keyring setup.r file to go about setting up your local settings. When we go through the script, there's 3 main steps that you have to take. You're going to first install the keyring package, and the keyring package is an R package that provides a secure mechanism for storing sensitive information. So in this case, we're going to be storing information about our connection string to our database server, the username and password, which we don't want to store in plain text within a script. So instead, we're going to make use of keyring to do that. And Strategus is actually making use of keyring under the hood. So it's important that we get this part set up to start. The second step is going to be adding the Strategus password to the R environ file, which I'll walk through how that works. And then finally, you'll want to configure your database settings and just replace the placeholders that we have inside of the scripts. So let me show you how that would work. Hop over to R. I already have the keyring setup.r file open, but you click this and it'll open up this script here. I have already installed keyring, so I won't repeat this step, but you could just run this specific command, follow the prompts, and make sure that keyring is all set up. The next part of this script is actually doing a check to make sure that you have, in fact, set your keyring password. And at the moment, I have not set that up, and what it'll attempt to do is actually call this command called use this edit R environ, as shown here. And in this error message, it'll actually tell you you need to add the Strategus keyring password SOS to your R environment file. And so I'll just copy and paste that here. Oops, pasted it one too many times. I'll save this, and most importantly, you need to restart your R session after you make changes to this file. Give that a second to restart. As I said, my R is a little slow on my machine, but here we are. So now if I run the same code block, because the password is set properly, I don't get any warnings or stoppage messages. And as a matter of fact, I can just confirm that that is properly set by running just this part of the command. All right. So next up, we need to provide the environment-specific values for your environment. So this would be where you would set your connection string information to your CDM database, the username, and the password. So in this example, I've used Redshift, but if you're going to use SQL Server or Postgres, some of these details may be a bit different. Jenna had a very handy suggestion, which is to check the database connector, create connection details, help file, which will give you some details on how to create the connection details specific for your database platform. Here, what I'm going to just do is I'm going to make a few edits so that you can kind of see that this is just something you could set. So if I want to say my server.aws.com port 5439, my CDM database, I'll put my username here, super secret password, and run this script. What the script will go about doing is it'll actually create a new keyring for you called the SOS challenge. It'll set the proper password, which we just set in our R-environ file. And then it will remove the SOS challenge keyring if it already was set up and create it from scratch. So you won't have any kind of holdovers from the previous runs if you did that. So if I were to run this now, you can see it's deleting the existing keyring because I've run this a couple of times in preparation for tonight. And you can see it'll actually emit the information that I set up top, just to give you a confirmation that everything that you wanted to set for your local setup is done. So once you've configured your settings, you're now ready to move on to execution. So to execute Strategist, we've included a uh, R script that's called the Strategist code to run. You would open up that file. We're going to go through what are the steps in which you need to accomplish to run Strategist. And really, it's just 3 steps here. You'll want to install Strategist. You'll want to specify where you would like the results output to go and your database settings. You'll also specify the connection details, but you won't really need to make any changes to that part of the script because it's going to just use the keyring values we set in the previous step. So let me go back to R and kind of show you what that looks like. So to install Strategist, you would install the remotes package first. The remotes package will then allow you to install any packages from GitHub, in this case, Strategist. And then you would source the Strategist library so that we can make use of some of the functions down in the script below. And in the scripts, we've tried to delineate where you are required to add inputs with some comments here. So I'll just walk through the various inputs that we are requiring. So the first piece is the connection details reference. So in this reference script, I was using JMDC. You could just replace that with your CDM name. The one note here about the connection details reference is it's used in 2 different ways. The first is that it's going to be the root folder that will hold all of your strategists and study results. And it'll also be used to store your connection details inside of keyring. The next piece that you need to specify is the output location where you want to write the results. In this case, I made it an output off of the root of the fluoroquinolone study directory. You could change that to a different drive if you had to, if you prefer to write your results to maybe a drive that has more storage, for example, or just customize where you would like that to go. The third piece here is the work database schema, and this refers to a database schema on your database server that you have write access to. So the work database schema is where you will hold the cohort tables, and so strategists and the modules themselves will need to be able to create and drop tables within this schema. So it's important that you make sure that you have write access to this schema. The next piece is the CDM database schema, and this is the schema that holds your patient level data that's been converted to the OMOP common data model. The min cell count refers to a value that is used to censor any sensitive information below a certain threshold within your results. So if your institution has a requirement to only share values that are above a certain threshold, you'd want to set that value here. We use 5 as a kind of minimum, but you can customize that based on your institution's needs. Next, you'd set the cohort table name. So we've kind of defaulted this to be the SOS fluoroquinolone aortic aneurysm abbreviated version of that study name here. You could make this whatever you want based on, if you already happen to have a cohort table that's called that, you could change it. One thing to keep in mind is that there are character limits on some of the cohort table names, or sorry, on table names in general for some of the databases. So you might not want to have something that's very verbose. One other thing that I will mention that's not in the script, but because Evan mentioned Google BigQuery, when you're configuring your database connection, you may want to provide the temp emulation schema as part of the options within this script. We didn't explicitly show that here, but that's something that if you're already using BigQuery, you're probably familiar enough to know how to do that. But if there's questions, just pop them in the chat and I can provide some resources on that later. And then finally, the connection details, it's going to source the values that we set in the previous script using the keyring setup. So you shouldn't need to change these, but you can, in fact, run this part if you just wanted to confirm some of the connection details or maybe even do a connection to your database to make sure that it's all ready to go. The remainder of the script you won't need to change, but I'm just going to kind of talk through what it's doing just so you're aware. So the next pieces of this are going to read in the analysis specifications JSON file. So this is what Patrick had put together last week on last week's call. And so this analysis specification is read in and it's used as part of the execute function for Strategist. We also store the connection details in Keyring as part of um, making sure that Strategist has access to those connection details so they're not being passed around. We establish the execution settings, which effectively use all of the inputs that we just talked through to make sure that we can execute the study and have all of the appropriate parameters set. And then finally, we set up the modules folder. So when Strategist goes to run your study, it'll check this particular folder to make sure that the modules exist. And if it does not, it will go out and download the modules from GitHub and make sure that the R, E, and V environment is set properly. And then finally, the last piece is to execute the study itself. And this is where Strategist will start to kick in and run all of the analytics. So let me show you on a different machine how that actually looks. Because I am running this study now, and as Patrick alluded to, the cohorts are a bit bigger, so it's going to take some time for them to run through. But I just wanted to kind of show you what to expect when you run the study. Okay, so this is on one of my computers. I'm currently running the fluoroquinolone study, and here you see that this is running, so I'm just going to scroll up in the output so you can kind of see what was happening at the onset. So on this particular computer, I had not installed the modules. So you'll see at the very top of this script, if I can get up to the very, very top, some of this got truncated. But what's happening here is that Strategist has started the execution, evaluated the JSON inputs, and has figured out that it needed to install all of the modules. When it's installing all of the modules, it's actually making use of RENV to download all of the dependencies and install them. So if you're familiar with RENV, you're probably familiar with some of this output, which is effectively RENV evaluating your machine to figure out what it needs to install or configure. Once it gets through the configuration of all of the libraries, it will start to actually execute the study, which is down here. And you will see that the study starts by generating cohorts and creating the tables for the cohorts to be stored. Once the cohorts are actually created, it then moves on to the incidence rate package. So show you where that is. So you can see here it finished generating cohorts. Then it starts the incidence rate. It's running the incidence rate. That goes fairly quickly. And now it's actually running cohort method to fit a propensity score model for the cohorts in the study. And that's currently what's happening. So once this runs, and this may take some time, it will definitely not be done by the time this call ends, but once that's done, all of the results will be written to the Strategist output folder. So let me talk a little bit about how do we actually review the output and review the CSV results. So I'm going to reference the anti-VEGF study from earlier today because I don't have fluoroquinolone results to walk through. So I'm going to walk through those results so you can kind of get a feel for what to expect with the fluoroquinolone study. So inside of the results, or inside of the database connection reference folder that I mentioned earlier, you're going to see a number of folders. The main output folder is called Strategist Output. This is where you'll find the results of each module that was executed. So below the Strategist folder, you're going to see a number of subfolders corresponding to the various modules that were run for the study. So you'll see things like characterization, cohort diagnostics, cohort generator, cohort incidence, cohort method, and so on and so forth. And so within each of those module folders, you're going to see a list of CSV files that hold all of the results themselves. And you could use your favorite text editor to go and inspect those, which is what I'll show you real quick on a different machine. Okay, so this is a run that I did for a different database. So JMDC, the Strategist output folder is as shown before. So you can see I have a number of different folders for each of the modules. If I were to go into the cohort generator module, for example, I could open up the cohort count CSV if I wanted to see the counts of the cohorts for the study. And in this case, like if we had values that were censored because they were below the minimum cell count, they would show up as negative values in this case, noting that they were censored. But in this case, there's nothing censored, so nothing to show that way. But you could effectively go through all of the output and take a look at this so that you could just verify all of the information before you contribute it back to the central coordinating center. So to go back to the slides, if you're at a point where you've got results, now you're ready to share them, we have another script within the same project that you could use for sharing the results. So to do that, you're going to note the database reference and location of the results that you used in the execution script. Those would be carried over into the share results script. And then you'll also need a key file name and a username that you'll get from Jody Ann and the study coordinator, just so that you can securely FTP the results. So let me show you what that script looks like. I'm going to bring over RStudio again. So here's the share results.r file that's in the root of the fluoroquinolone project. If I open that up, you'll see at the very top of the script, there are the connection detail reference and output locations, which match up to the Strategus code to run that I had shown you earlier. And then you'll need the key file name and username, as I mentioned before. For now, there's some placeholders that we had from the COVID-19 studies, just so that you can kind of see what those might look like. And all this script is doing is it's zipping up your results that are in the, in this case, in the JMDC folder. And those zip files are then uploaded via SFTP to a secure location for contribution back to the coordinating center. So they'll go into an FTP folder called SOS FQ. So to summarize where we are, we downloaded the zip for the project from GitHub. We unzipped the folder into a local directory and opened up the project. We then configured the project using the keyring setup.r script to make sure that we have the database connection settings and keyring password ready to use. We execute the study using the Strategus code to run.r to edit the local output directory and database parameters, and then you can actually just run the study using those settings. Once that's done, you can review the results using text editor to review the CSV files, or you can launch a Shiny, which I'll show you how you go about doing that in a moment. And then finally, you can share the results using the share results script that I just showed earlier. So when we have all of the results available as CSV files, you might want to be able to just kind of load them into a database and take a quick look at them using a local Shiny viewers before you contribute them back. And we supported this by creating a couple of scripts that you can run to create a local SQLite database with your results, and then use that to launch the Shiny viewer. So I'll show you how those resources work. Just for reference, the scripts that you're going to use are called Strategus results upload.r. And again, you're going to want to set at the very beginning of that script the two parameters, or the two inputs, for your connection detail reference and the location where your output lives. Additionally, you'll have an app.r file that'll open up the Shiny viewer. And again, you'll just want to make sure that your connection detail reference and output location are set consistently in all of these scripts. So let me show you how that bit works. Coming back over, again, since I don't have results for the fluoroquinolone study, I'm going to use the anti-VEGF as my exemplar here. So just to kind of show you the results upload script, again, you would set these connection detail reference and output locations based on what you set when you executed the study. And then all you would need to do is just run this script. And what this script is actually going to do is it's going to take the output that's in your Strategus output folder. It's going to create a SQLite database in your output location, and then it's going to go about establishing all of the tables and uploading the results into SQLite. So I'm not going to run that just due to time, and I've already done that, so it's already available. So I can just kind of show you on the file system. We're going to go into my output directory. The results SQLite has been generated. Just ignore that copy. That was just a backup. And now what I would like to do is actually run the Shiny app so I can view those results. In order to do that, you are going to want to install a few of the necessary prerequisites, which is the Odyssey Shiny App Builder, the Odyssey Shiny Modules, and the Results Model Manager. Once you've installed those 3 packages, again, you'll set your connection detail reference and output location as you've done before, and then effectively you just run this app. So if I click on Run App, it's going to connect to that SQLite database that I have, and it's going to allow me to browse the results. So I'm not going to go through the Shiny viewer itself because that's going to be covered a bit next week, but just maybe highlight like what the app has at a high level. It provides some information around your cohorts, so the cohort counts, how long they took to generate, cohort diagnostics that have been generated for those cohorts. We have the ability to explore characterization details that have been produced for the cohorts in the study. The estimation tab is going to allow you to review the study diagnostics as well as results that have passed diagnostics. The self-controlled case series similarly will allow you to review those results, and prediction as well allows you to kind of go through, review those diagnostics as well as view the results. So let me wrap this up here. I'll skip these couple of slides because I talked through these, but we will have a central Shiny app that will have the fluoroquinolone study results once they are ready and available. So we'll just request that you can check out that app during the week as more results are added. So let me stop there and stop sharing so that Chungsoo can take it from here and present his work. I'll try and answer any questions in the chat while that's going on.
Can you see my screen now, right?
Yep, we can see it.
Yep. Hi, my name is Chungsoo Kim. And maybe I will repeat everything Anthony said right before using my database setting. As you already know, the strategy study script can be executed with 5 simple steps. I followed all the steps with our database and our database settings. Maybe it would be great if you, the first step was the downloading study project. This was super easy. You can just download directly in the GitHub repo, or you can download via terminal or GitHub Git bash using git clone command like below. Then you can see this study repo in your R Studio like right side. Then you have to open the study package project file named fluoroquinolone aortic aneurysm. Then and also you can also see files like hearing setup, study code, strategist code to run file, results upload file, and app file. And in the inst folder, you can find the JSON file specified in the last tutorial. We used this file for the study execution. And the second step was configuring some information. If you have previously set keyring, then you need to set up a keyring first. I can find the settings script in our working directory named keyring setup R file. When you open it, you can see this script. And you should provide information about your own database. If you have in the SQL server, you have to write down SQL server in the DBMS. If you have on Amazon Redshift Cloud, then you have to set the DBMS as Redshift. And you can put your connection string for the database connection using JDBC. You can put like this, including DBMS IP address and port number. This was also depending what was DBMS you use, because I used MS SQL for the CDM database. I put a CDM connection string like this format, for example. And I also need my login information like username and password. And for option, if you are not familiar with the connection string, then you you can just use the server and port variable for the connection detail. And following the description, we have to set environment variable name Strategus keyring password only for the first time. If you run the edit our environment function, then a new window will be popped up like this. Then the new window will be popped up, and then you can put the below line just like that and into the new pop-up and push the save button here, and then it will works for the next command. And the default password of the keyring is set as SOS for the convenience, so I recommend keep this password. Then you can have to run the part below as is, and all the things to run in the Strategus code to run file. So you can open this file. First of all, you have to install the Strategus package before executing all other parts. And after the installation of the Strategus, you have to set another environment variable once again named instantiated module folder like this, and which is set where the downloaded modules are stored when you set a new environment variable. And please list our URL for applying your environment variable. And next was the connection detail reference. You can put any word for the reference of your database connection, but I prefer that putting this with the name of database. So I put this with NHIS, which was our database name. Now we can use the keyring for the connection detail because we already set each key in the keyring. If you set the server and port information in your keyring rather than the connection string, then you can use like below. And if you use Linux or Mac user, then password pop-up will be appeared like this. Then you can type just SOS because we already set in the keyring script. Then yeah, the connection details was done. And after finishing the connection detail, we have to set the schemas for finding right schemas for reading CDMs, writing result in my database. So I put the cohort db.dvo, which is my schema I can write into the work database schema. And CDM database schema, I put our database schema name here, sum531.dvo. And output location was a directory for saving all results. I put like this. And cohort table name is a name of data table will be written in your database. So I like this name, so I didn't change that. And that was the end of manual configuration of my database. And the next step was execution of our study. To execute the study, simply run the following lines. When you execute, it start downloading all the module from GitHub based on the study JSON you specified. And after establishing all environment like dependent package necessary for the running each module, and analysis are performed as specified in JSON. And study will run from few hours to several days depending on your data size. When the analysis are finished, and the numerous result file will be created in the output folder. All result files correspond to each module will be created. And I also can got some result with my database in the output folder like this. I used the NHIA database and I got some beautiful outputs in here, and I can see all the results from the different modules like this. And yeah. And yeah, we can actually manually review lots of the result in the output folder, but we can use, for more efficient way, we can use a Shiny app dashboard. And then I thought two steps. I need two steps for learning Shiny app. The first one was the upload our result into the SQLite database. And the second was that the run Shiny Bureau using this database. For the two steps, I could run the Strategus result upload R file and apps R file in the study project with simply fixed connection, detailed references, and output location in my site. When finished to upload result into the SQL server, you can find the SQL file in your output location. And using the SQL file, now we can see the result using online Shiny app. And please open the Shiny app R file and change the input according to your settings. After saving the file, then now I could click the button Run App like this. Yeah, go to the app R file and I fix the connection detail references and output location. Then I can push the Run App button. Then a new window popped up and you can see all the results from the cohorts, code diagnostic, characterization, estimation, SCCS prediction module in the one Shiny application. Yeah, maybe exploring more in depth will be at the next tutorial. And finally, I can use the share result R file to share our result. Please modify the connection detail references and output location in the same way before, then put the key file name received from the study coordinator and execute all the line below to send our result. Then your result will be forwarded to the study coordinator through the Odyssey SFTP server. Yeah, it was my experience with the Strategus project for the fluoroquinolone study. If you guys have any questions or comments, Chan?
Yeah. At the beginning of the Strategus execution, the Strategus has set the environment by using RNV, and sometimes we do our environment is completely offline within the intranet. So is it possible to run Strategus in the environment without online connection?
I've discussed with the situation with offline with Jenna before. Then we thought that we need another setting with the internet connection, and in that environment you have to download all the modules with the internet connection and move all the study package and modules, and you can move those into your offline environment, and then theoretically it will work.
Theoretically, okay.
Yeah.
I will try. I will try since my institution.
Sena,
any comments,
I know
Sena?
I know you've been working with Mark. Do you want to just comment a little bit more specifically about what you guys are planning?
Yeah, actually, what Chungsoo just described is what we're planning to do. So effectively, if you were to run the analysis specification as we've shown, and it'll attempt to download all of the modules and set up the R environment, you should be able to then port all of those files in the file system to your offline execution environment. It should work. That's still, as you mentioned, theoretical, but we believe that should work. May require some configuration with RENV itself. So RENV has options to specify where you would like to store the cache, for example.
Yeah.
So it may be that you need to be very explicit around where you would like to have those resources stored on the file system to make them easier to move. For example, like on Windows, usually that goes to like your users directory, and that may not be something you want to port to an offline server.
Okay, thanks. And another question of mine is that so the current JSON file, JSON setting of Strategus is compatible with Atlas JSON file, JSON setting of execution.
No, those are different.
Yeah, they're different format.
So the parts that are the same, Chan, is inside of there, you'll see JSON that represents a cohort. So the cohort is straight out of Atlas. So that JSON is the same. But the one of the main goals we actually had for Strategus was to, for the first time, create the idea that there was a JSON specification for all the analyses. And as you've previously experienced, in Atlas currently, there is something that looks like a JSON that is basically for estimation. There's something that looks like a JSON that's for prediction, but they're different. They're not compatible. They go to their own skeleton packages that have to be hydrated to make them work. So like this is a replacement approach for that, whereby we have, you can think of it right now, we have one script that produces one JSON that runs for all modules, and we make everything follow a consistent pattern. At some point in the relatively near future, we anticipate, like as a community, we will build a user interface to design the JSON input specification. For right now, it's just an R script that you can just execute to produce a JSON. So it's not that cumbersome, but it's definitely a task left for a programmer at the current state. It's not for the faint of heart. But in relatively shorter, I'm sure within a couple months we're going to have an operational UI to allow you to kind of like point and click through. And you could imagine that UI in subsequent points, like that would be what we would imagine be like the future of Atlas could be purely as a designer of this object instead of the legacy approaches that are currently in there.
Yeah, but it's really tremendous. Yeah, remarkable breakthrough of Odyssey that we can have some, really unified that package it to run, execute several other modules at once. Thanks.
So Chungsoo, I have to ask, what did you find in your study since you have results on your screen? Did you
Sorry?
pass any? Did you pass your diagnostics?
No, I failed the diagnostic, but I just run the study for the presenting.
Got it. Okay, good. Well, by next week, when Nicole and Mitch are going through study diagnostics, we will. I predict we will have results that are passing diagnostics as well that we'll be able to go through. But I want to encourage all of you who do have access to data to, now that you've seen that it's relatively straightforward to run, we do want you to go through the process of running, and then once you verify you're comfortable sharing the results, pass them along, because what Nicole and Mitch will go through next week will be the process that we will follow for reviewing all the results of all the databases who contribute. And certainly on the J&J front, where I know Sena has multiple machines fired up and running the fluoroquinolone study as we speak. So we'll definitely, we're eager to contribute the results as soon as we have them.
I guess I need a faster machine, Patrick. That's all.
Jenna definitely had the advantage of being able to show the study that was running live while she was presenting because it was faster. This pesky study that's got millions of exposures is not going to be a real-time analysis. But given that the alternative would be us trying to cobble together a study that would certainly have taken many, 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 many months, the idea that you're going to have it done in a couple days will be passable.